Hello, this is Ylock number 35. So Pythagorean theorem, and we're just using this equation once again. So we have a is 4, so it'd be 4 squared plus b squared, because b is not there. We're trying to find out what b is, and we know that it equals c squared, which is 5. So we can replace it with 5 squared. 25 equals b squared plus 16. Subtract 16 on both sides, and you get 9. You know that the square root of 9 is just 3, and that's what your b value is equal to. Moving on. Now, we're adding and subtracting rational expressions. So basically what that means is we're trying to subtract this. In this case, we're trying to add them together. So u minus v over 8v plus 6u minus 3v over 8v. So whenever we're trying to add rational expressions, what you have to do is you have to make sure to remember that the denominators has to be the same. If it's not, then we have to find out the least common denominator, the lesson that we learned last week. And with that knowledge, we can find the common denominator, and then we can add the two terms. In this case, we already have the same denominator, so we can just add them together. They're all over 8v u minus v plus 6u minus 3v. Negative v minus 3v is negative 4v, so we can put negative 4v, and 6u plus u is just 7u. All over 8v, and that's our answer. Moving on. 2 over 3x squared plus 12x plus 8 over 2x. In this case, their denominators are not the same, so we have to find the least common denominator. In this case, a trick in finding the common denominator is to just multiply the denominator of the other term. So let's start with 3x squared first. The other denominator is 2x. So what I do is I can just multiply 2x on the bottom. Now, I can't just do this. I can do it, but there has to be a specific way that I should be able to implement this. I can't just do 1 over 2x on one side. What I have to do, because I can't just make up numbers, they have to come from somewhere. Now, how am I going to derive 2x though? Well, I can make it 2x over 2x. Since 2x over 2x is just equal to 1, this is basically 1. So I'm basically just doing 1 times 2 over 3x squared, which is still 2 over 3x squared. So I'm actually not changing the value at all. Now, this is prepared. Let's go into the second part of it. 2x. Well, the other denominator was 3x squared. So what I can do is I can just multiply 3x squared top and bottom. Now, it just comes the algebra. 2x times 3x squared, well, that's a that's a combination of 6x cubed. That's the same for here too. And we just multiply 2x times 2, which is 4x, and 3x squared times 12x plus 8, plus 12x plus 8. Now I just distribute this 3x squared to each of the terms in the parentheses. 4x plus 36x cubed plus 24, because 8 times 3 is 24, x squared. We can't combine any like terms, so what we can presume that we are done. But however, there is another step to it. We can actually simplify. We can simplify the x, because we can see that there's an x here, there's an x here, and then there's an x here. There's an x for each term, so we can cross that out, leaving you with 4 plus 36x squared plus, backtrack. I said that it was only x, but there's also another factor we can simplify by. We can simplify by 2, since these are all even numbers. If I do that, then I get 3, I get 12, I get 18, and I get 2. So as a result, I am left with 2 plus 18x squared plus 12x over 3x squared as my final answer. Moving on. 6 minus x plus 5 over 7x minus 5 times x plus 4. In this case, this 6 has a denominator of only 1. Now, because they're not the same denominator, we got to make sure that they are. So how do we do that? Well, how do we do that? What we have to do is, there you go. What we have to do is we have to multiply the opposing denominators of the other side. If I do 7x minus 5 times x plus 4, let's start with here, and then I just multiply by 1 on the bottom and times 1 on the top. Remember, I'm just multiplying each term by 1. By 1, considering that 1 over 1 is still equal to 1. 1 over 1 is still equal to 1. So I'm not changing anything. The value is still consistent. Now, for this side, the opposing denominator is 7x minus 5 times x plus 4. So I got to multiply that top and bottom. Top and bottom. Plus 4. Now, our conclusion is 7x minus 5 times x plus 4 times 6 minus x plus 5 all over 7x minus 5 times x plus 4. Now, what I'm going to do is I'm going to expand this. Presumably, you can leave it alone like this, but I'm going to take it a step further. I'm going to multiply out this so that I can see what I can simplify. 7x, let's start with this first. 7x times x is 7x squared. Negative 5 times x is negative 5x. Negative 5 times 4 is negative 20. Subtract 7x times 4 is 28x. Positive 28x. Let's review. 7x times x, 7x squared. 7x times 4, 28x. Negative 5 times x is negative 5x, and negative 5 times 4 is negative 20. Now we have to multiply all of this by 6, and because this is a negative, we have to distribute that negative to each of these terms. So that would be negative x minus 5. Now 7x minus 5 over x plus 4. We have 7x times 6, which is 42x squared, minus 30x, plus whatever 28 times 6 is, which is 48, 12, 16. Yes, 16. So 168x minus 6 times 20, which is 120 minus 6 minus 5, all over 7x minus 5 times x plus 4. Now, what I can see here is I can actually combine like terms. Which terms? This one, and this one. I can also combine this and this. If I combine those, then what will I get as a result? Well, I know that it's 42x squared, 168x minus 30x. That only leave you 138x. Now you're subtracting x again. So that would leave you with only 137x. Negative 120 minus 5, well, that's just negative 125. All over 7x minus 5 times x plus 4. And that is your answer. Now, remember, this answer is the same thing as this answer. They're equal to one another. I didn't simplify this out because it's a tedious task. But if you were to simplify it, this would be your answer. That's it for Wylock number 35.